Hello, welcome. In the last video, we looked at few ways of finding the minimum number in an integer array. This is the last version that we looked at. Here, we declared an array of size 100 and assumed that the actual number of integers of which we are to find the minimum is at most 100. So, here is the declaration of an integer array of size 100, and then this scanf statement asks the user for the number of integers that the user will enter, and then it stores the response of the user in the integer variable n. The following for loop takes in n numbers through the keyboard and stores them in successive locations of the array A. Then the rest of this program finds the minimum element of this array and prints it onto the screen. The advantage of this is that we have a single program that can handle various number of elements as long as the number of elements is at most 100. The disadvantage is that it is possible for the actual number of elements to be much less than 100, and in that case much of this array A will be unutilized. Here is our second example of this video. Here we compute the grade point average of a student in a particular semester. So there are two arrays that we declare named grade underscore pt and cred respectively, of size n sub. N sub is a constant integer initialized to 6, and the qualifier const says that its value will not change all throughout the program. We have three integer variables I, gp underscore sum and cred underscore sum, and we also have a double variable gpa, which will eventually at the end of the program contain the grade point average. So these two arrays, grade underscore pt and cred, will store the grades earned and the credits of each subject. So this is an example of using parallel arrays to write a program. This for loop reads from a user the grades and the credits of each subject. So think of the grades as a discretized version of the usual grades like EX, A, etc. Think of AX corresponding to 10, A corresponding to 9, and so on. And credit of a course is the number of credit points that you earn if you do that course. The number of credits of the PDS course, for instance, is 3. So for each of the 6 subjects, the user enters the grade and the credit. And then they are stored in successive locations of the two arrays, grade underscore pt and cred. That is, the grade and the credit of the first subject is stored in grade underscore pt 0 and cred 0 respectively. The grade and the credit of the second subject are stored in grade underscore pt 1 and cred 1 respectively, and so on. So for each I from 0 through n sub minus 1, that is from 0 through 5, grade pti and grade I store the grade and the credit of the I plus first subject. Now, how is the grade point average computed? Well, you multiply the grade of each subject with the credit of that subject and then add this product over all the subjects and then divide the sum by the total number of credits, which is the sum of the credits of all the courses. So it is really a weighted mean of the grade points where the weights are the credits, the various subjects. So this for loop here computes the weighted sum of the grades and the sum of the credits of all the courses. In a particular iteration, it adds the product of grade PT I and grade I to GP sum, GP underscore sum. GP underscore sum is initialized to 0, and in the ith iteration, we add to it the product of the grade and the credit of the ith subject. In the ith iteration, we also add the credit of the ith subject to the variable grade underscore sum, which is also initialized to 0. So at the end of this for loop, the variable GP underscore sum holds the weighted sum of all the grades. That is the sum of the product of grade and credit of each subject. The variable grade underscore sum holds the sum of all the credits. Thus, now to compute the GPA, we should divide GP underscore sum by grade underscore sum. We would like the result to be a fraction and we would like to perform a real number division. However, GP underscore sum and grade underscore sum are both declared as integers. So the division will be an integer division. To actually get a real number, we typecast GP underscore sum to double and then divide GP underscore sum by grade underscore sum. Then this division is the division of a double variable with an integer, and hence by the rules of type conversions is interpreted as a double number. The result of this division is then assigned to the double variable GPA. Thus, after this step, the variable GPA holds the grade point average of that semester of this particular student. This printf statement prints out the grade point average of GPA. It prints out the grade point average, which is the value of this variable GPA. Our next example is a program that solves a fundamental problem involving sequence of numbers, namely sorting. In sorting, one is given an array with n elements. Think of these elements as numbers for now, but later we will see that the elements can be more general. The task is to arrange those elements in ascending order. Sorting is a well-studied problem in computer science, and there are various sorting algorithms. In this presentation, we'll look at a very basic and simple sorting algorithm which is called selection sort. There are more sophisticated and more efficient sorting algorithms, some of which we will see in subsequent lectures. Let me tell you the basic idea so that we can do by hand the sorting. After we have understood how to do it by hand, we will write the program that implements the strategy. Remember, just to remind you, we are given an array of n integers and the task is to arrange the elements in ascending order of their magnitudes. Our procedure will proceed in iterations. In the first iteration, we find the minimum number of the array. Just for the sake of a concrete example, assume that the minimum number of that array is A6, that is the 7th element of the array. Then we interchange A6 and A0, that is exchange their contents. After this step, A0 holds the minimum element of the array. Note that in the ascending sequence of elements, A0 is supposed to hold the minimum element of the array. Thus, after we do this, the first element of the array is in place, and we will now just have to sort the rest of the array. What we do after that is we find the minimum of the remaining n-1 elements of the array. This minimum that we find in this step, note, is the second minimum element of the entire array. Then we swap it or interchange this element and A1, which is the second element of the array. After this step, A1 holds the second minimum element of the array and A0 continues to hold the minimum element of the array. Hence, we have the first two elements of the array in place and we'll have to take care of the rest of the array. We continue this until there are no more elements left, and at that point, our entire array is sorted. This program on the screen implements this basic idea. Let's now go through this program. A100 is the array that will store the elements that we need to sort. There are other integer variables in these declarations. We will see later what their roles are in this program. This scanf statement asks the user for the number of elements and stores it in the variable n. The following for loop reads n elements through keyboard and stores them in the first n locations of the array A. The array A has size 100, of which only the first n will be used. In this program, we will sort only the first n elements of the array A and will not bother about the contents of the n plus first through 100th element of the array A. The next for loop implements the idea that we went over in the last slide. Let's try and understand the first iteration of this for loop. So let's assume for the time being that I is equal to 0, which corresponds to the first iteration of the for loop. Recall from the last slide that the first task is to find the minimum element of the entire array. Yeah, and this is what this loop does in the first iteration. The variable min is initialized to A0, which is the first element of the array. The variable pos is initialized to I, which is 0, that is the first index or the index of the first element of the array. This for loop goes over the remaining n-1 elements of the array. J is a index of this for loop which takes values from I plus 1 to n-1 and is incremented by 1 in each step, in each iteration of this for loop. Wherever we see that Aj is less than min, that means that we have found an element that is less than the minimum element that we have found so far. Then we update min by assigning Aj to it and update POS by assigning j to it. So we ensure that min holds the minimum element that we have found so far, and the variable POS stores the index of the minimum element that we have found so far. If we find an element aj which is less than the current min, we update both min and pos. After the execution of this for loop, the variable min contains the value of the minimum element of the array, and the variable pos contains the index of the minimum element of the array. Recall that the next step is interchanging the minimum, the array element that contains the minimum element of the array and a0. This is done in these three statements. We have seen before how to interchange two elements. So here we bring in a temporary variable temp. We transfer a0, so recall that I is 0, we have assumed. We transfer the content of a0 to temp, and then the content of apos to ai, which is a0, and finally the content of temp to apos. And the net effect of doing this is that the contents of a0 and aj are interchanged. Finally, we print the current array. After each iteration of this for loop, we print the current array so that we can visually see how the algorithm progresses. This is what happens in the first iteration of this for loop. In general, in a certain iteration, we have already put so let's say in the tth iteration of the array, the first t-1 elements of the array already contain the t-1 smallest elements of the entire array in the right order, and in the tth iteration, that is when I is equal to t-1, you find the tth minimum element of the array and put it in the tth element of the array. I leave it to you to convince yourself that this is what a particular iteration of this for loop does. Let's visually look at the output of this program on a certain input. Here, first the user enters 6 to indicate that the user is going to enter 6 numbers. Then the user enters the following 6 numbers: 7, 12, 5, 15, 17, 9 in this sequence, and they are stored in the array. In the first iteration of the for loop, this for loop, recall that the minimum element of the entire array is found and it is interchanged with the first element. After doing this, 5 and 7 get interchanged, and this is the resulting array. Note here that the first element of this array is 5, which is the minimum element of the entire array. In the next step, we find the minimum element of this portion of the array, that is A1 through A5. This minimum element is 7, and then we interchange it with A1, which is 12, and the resultant array is written here. So after these two iterations, the first two locations of the array contain the two minimum elements in the right order. In the third iteration, we find the minimum of 12, 15, 17 and 9 and interchange it with the third element of the array, that is 12. That is, we interchange 9 and 12, and the resultant array is written here. In this array, the first three elements are the smallest three elements of that array, of the array written in ascending order. In the next step, we find the minimum of 15, 17, 12 and interchange it with 15. The minimum is 12, it gets interchanged with 15, and this is what the array looks like. 5, 7, 9, 12, 17, 15, and the first 4 elements are the four minimum elements in ascending order. In the final step, 17 and 15 are interchanged because 15 is the minimum of 17 and 15, and you interchange 15 and 17, and this is the array that you get. And once the first 5 elements are the minimum 5 elements of the array, the 6th element is automatically the 6th minimum element of a 6 element array, and it's already in place. So this is the sorted sequence, as you can see. Here is a slightly bigger example, and I encourage you to go through each step of this and follow what's going on. We'll end this video by listing a couple of things that you cannot do. We have already warned you that arrays cannot be assigned to other arrays directly by using equality operator. You have to assign one array to element by assigning one array to another by assigning each element of this array to the corresponding location of this array. Similarly, two arrays cannot be compared directly by equal to operator. If we want to compare that two arrays are equal, that is, all the elements of the two arrays are equal, we will have to compare each element of one array with the corresponding element of the other. That is, we will have to compare if AI is equal to BI for each value of I from 0 to size minus 1, where size is the variable that stores the sizes of the arrays A and B. That's all for this video. Thank you.